So we're the paired AR drone team. Does anybody know what an AR drone is? Has anybody heard of it? All right, it is a recreational quadcopter that's used by a lot of students and just by a lot of people who are enthusiastic about just using remote control flying stuff. And so let me tell you a little bit about the AR drone. We built a LabVIEW interface for the AR drone so that you can control it using your computer. Basically, when you buy the AR drone, it's intended to be used through an iOS or Android app. So the way it works is the AR drone, which Tim can kind of hold up right there. Can you all hear me okay, by the way? Cool. It actually broadcasts a Wi-Fi signal. So a Wi-Fi signal that you can just attach to with your phone, and then using your iPhone app, you can just control the AR drone. So that's typically how you control it. But we said, let's try to use LabVIEW. So the people at Parrot actually provide an API, so a set of code that you can actually write. And if you send those commands to the AR drone, you can actually control it over that Wi-Fi signal. So it actually has a mounted HD 720p camera on it. You can stream up to 360p just because Wi-Fi signals can be a little shaky sometimes. It has a light carbon fiber structure, so it's pretty aerodynamic. It can also do some pretty cool animations or tricks, which might be a better word for it. We might show you some of those later on. And it also has built-in stable flight algorithms, so you don't have to worry about like pitch, roll, and yaw, and all of those really complex algorithms yourself at all. You don't have to be an aerospace engineer. It takes care of all of that for you. With that, I'm going to turn it over to Justin, who can explain a little bit more about the details of the toolkit.
Alright, so here's just a little overview of how the toolkit itself interacts with the AR drone. So basically we can take input from many different sources, so like gaming controllers, you can use automation, or like your keyboard and mouse, really anything that can talk with LabVIEW at all. So we use that to communicate to LabVIEW, and then we actually connect with the PC to the AR drone's Wi-Fi network, as Robert was saying, and then we actually control it by sending commands over UDP as well as TCP packets. And all those are defined in the API, which Parrot actually outlines. So we just implemented their guidelines with our LabVIEW VIs, and we basically translate the input here into commands to the AR drone. So all the communication, like I said, is done over Wi-Fi, and we also use the standard LabVIEW open control closed architecture that you're probably familiar with. So as you see down here, we open the connection to the drone, we loop through, sending our control signals, and then finally, when we're done, we close out our AR drone set. We're able to control the pitch, roll, yaw, and vertical speed of the drone. And so we also receive some data back from the drone. So it also, it sends navigation data over the network back to the host machine. So this data includes like battery data as well as some flight parameters, some of the stuff that's listed here. And so you can use that for processing on the computer end if you want. We also receive video data from the drone. So it transfers video data over the network after you request it to the host computer. We actually use an open source piece of software to decode this. It's in H.264 format. It's called FFplay. It basically just takes the stream, decodes it, and shows it on the screen. And so now, hopefully we'll get to have a little fun and show you guys how this thing actually works.
Alrighty, so Justin, who just spoke, he's going to control the VI, so he's going to run it over there. And Tim, your lives are in his hands. So he's going to be actually operating the Xbox controller. So we actually started reading in data from a wireless Xbox controller and translated that into basic commands that the AR drone takes. So that's kind of how this is going to work. I'm going to step out of the way, I think, right? Should I step out of the way? Okay. Step out of the way. It's actually a pretty relatively safe quadcopter. Like it actually has a lot of safety mechanisms built in and whatnot. So don't be too scared about it. We've flown it in front of small children before. All right, cool. So as you can see, you can already see the video data coming in from the AR drone. We're already connected to it, and so I'm actually right. All right. All right, so Tim, go ahead and lift off. There we go. Uh-oh. All right, so as you can see, it responds to Tim's commands to do some basic forward and backward movement and twisting movement and whatnot. In addition, so this is just basic movement that you could do with the iOS app, but you can also do it with our Xbox controller in this case. We've had some people just pick up the Xbox controller and start flying it. It's extremely intuitive. So this is not something that was available until we hacked it. One thing that we can do that we built in was using the previous Twitter API that was discussed. We actually were able to start tweeting pictures that were coming from the AR drone. So Tim, if you can get if the audience can kind of wave, maybe smile a little bit. Let's see if we can get a good picture of the audience and tweet it. All right. So all Tim has to do is hit the Y button, if I'm not mistaken. Or not hit the wall. That helps. Okay, here we go. Oh, it's up there. Boom, there it is. Okay, so you can go on Twitter on the LabVIEW hacker page. You can actually see the picture of you guys right there. If the light was a little better, it would have been a little bit. There you go. There you all are. Excellent. So there it is. And we have one more tiny feature that we wanted to show you guys. So we built in a little something that's hidden. If you guys played video games in the 90s or even recently, you might have noticed this. But Tim, can you show them what we built in? All right, thank you all very much.
All right, so we'll get back to the talking about that presentation again.